Hello, we're just going to start with linear equations. I'm going to say that most of you are fairly well adept in all of this, section 1. But some of the problems, again, are a little bit more extensive. So there is some terminology that I wanted to go through a little bit. When you are solving a linear equation or any equation, those would be considered your solutions or the roots. Those are the values that make it true. Oftentimes, in a more formal setting, you write those values in a solution set. So sometimes you might have 3 worked and 7 worked. Other times you might just have -2 worked. Okay? So we could list all those in there. There might be more than one. If there is nothing in there, you could always do it like this, which means empty set. That means no solution. Or the more common symbol for no solution is no solution, nothing works. Equivalent equations have the exact same solution set. So if I said that I had x plus 3 equals 0 and x squared equals 9, -3 satisfies both of those equations, but the bottom equation also is satisfied by a +3. So those would not be equivalent equations, okay? But they have the exact same solution. So they say that a linear equation they consider to be in this form, where you have one variable and the highest exponent of that said variable is a 1. So linear equations are first degree equations. So you don't have any exponents higher than 1 of your variables. So we have a couple of examples we want to go through real quick. Chances are you can pause these and double check your work and make sure you're on the right track. So I'm going to distribute the -4 to get -12x and +20. Over here, I'm actually going to distribute like a -1. So this becomes a -8x and a -7. Sometimes when there's numbers here, people will forget that the negative goes with that. Okay, but keep that straight. There's multiple ways to do this. I like to combine like terms on the same side first, personally. So I would have a -8x and a -4. I'm going to add my 12x over. And then I'm going to add the 4 over. I have 24 equals 4x. And my divide by 4 and I get 6. And I should always check my answers. If I put a 6 in here, that's 18, 13. 13 times -4 is -52. Over here, 6 times 8 is 48 plus 7. So 55. And 3 minus 55 is, in fact, a -52. So we're good. All right. And I could write this in a solution set, such as this. Okay. Over here is another one, and this one has fractions on it. So I'm going to solve this one a couple of different ways. One way, maybe, is to go ahead and get rid of all of the denominators. So if you notice here, I have a 3 times 4, 2 and 3. All these numbers go into the value 12. So I could multiply both sides by 12. It's a property of equality. Another thing I could do then, basically each and every term gets multiplied by the 12. So if I take the 12 times the 2x plus 4 all divided by 3, that reduces to just be 4 times that. Here it becomes 6 times 1x. And then over here it becomes 3 times the x minus 7 times the 4. So again, I just distributed that, and the purpose of that was to get rid of the fractions, so like our complex fractions before. And from here we could distribute and solve this. So I distribute the 6, not the 6, the 4. Combine like terms. And start to subtract. So subtract the 3x over, leaves me with 11. Subtract the 16 to the other side, and that leaves me with a negative 44. So x equals negative 4. So my solution set is exactly that. The other thing that I was wanting to mention was that I'm going to go above here a little bit. That x over 4, if you want to do x over 4, is the same thing as writing 1/4 x, okay? Or this 1/2 x. So I wrote them both ways just so you can kind of see that. There's different ways to write that. If you really wanted to, you could have distributed and made each of these terms separate. Equals 1/4 x 7/3. So you could have done this as well. So if you only have one number in that denominator, we can distribute that through the bottom. Okay? From here, we're going to move on. So hopefully that works out. I should double check it. Negative 8, negative 4/3 plus a negative 2. And then I have a negative 1 minus 2 1/3. Yeah, definitely works. So, a couple of things that I don't know about you. Your book says a little bit differently than I anticipated. So, conditional equation, basically most of the time you're going to have one solution for a linear equation. And they're saying that's conditional because it is true under some conditions, but not others. So, like an if-then. If x equaled negative 4, then it would be true. Identity might be a word you're familiar with. This would be a situation where any number will always work. So they actually write it as a solution set, and they put all real numbers inside. Something your book doesn't do, but if you wanted to, you do this little fancy R. That means the set of all real numbers. It means the same thing. Contradiction would be when you would oftentimes write no solution. Okay, but the symbol for that, like I already said, would be no solution. Or they might write it as an empty set. Okay? Otherwise, you just go about it like you normally would. All right. So the next part of this is where they're just basically having you double check your skills. So if we wanted to solve this equation, this right here is the interest. The interest, like a financial, is your principal or your beginning investment or balance times the interest rate written as a decimal, and time often in years. Okay, the reason the time is in years is because that's an annual percentage rate. Okay, if your rate was given in different time spans, it could be figured out differently. So they want us to say that we wanted to know how long I need to leave my money in somewhere to get it to a certain point, right? Or how long did we have that invested? Instead of solving the equation over and over and over to have this interest, one could just change the equation of the formula. So to solve this for t, this is all multiplication here. So principal times rate times time. All I'm going to have to do is divide by the principal times the rate. So the interest divided by the principal times your interest rate will equal the time it was invested. Okay? Now, if you were to add your interest onto your previous amount, so basically, somebody once upon a time says, what's my ending amount? My ending amount is I take my principal balance plus my interest, right? That's basically what they're saying here. They're just manipulating it a little bit. All right? So we're going to go ahead and solve this for P. So when I solve this for P, and what you notice is I have two different P's. Last time we just had one T. So what we're going to do is we're going to factor out that P as a GCF. And remember, something divided by itself is 1. And then I can divide. So this right here is a little bit more familiar to what we're used to using, especially like when we use logarithms and exponential. Similar to this, but to get P all by itself, I would take my later amount, my account balance, divided by 1 plus the rate times time to figure out that principal amount, okay? Or how much I needed to invest to make it work. So you could just use it accordingly. Okay. Here's a little bit longer one. So this is where I say this is a lot like what we've done before, but it gets more confusing. So they want us to solve this one for y. So I'm going to go ahead and distribute the 2 on the right-hand side to make that an 8y and a 10w, but I don't have to distribute to the 6z because it's not inside the parentheses. I want to get my y's on the same side, so I'm going to subtract this 8y. So I have 3y plus 8 equals 10w minus 6z. I'm going to subtract this 8 over, but it's not a like term. There's no other constants right now. So I'm just going to put at the end as my constant term, and now I'm going to divide everything by 3. And I could either multiply by 1/3, and I could distribute it through, but most of these numbers aren't divisible by 3, so I'm just going to leave it like this. Okay, so we solved that one for y. There's one more example I wanted to look at, and we're utilizing these interest problems. So it's from your book. It was example 5. It says that a woman borrowed $5,240 for new furniture. She will pay it off in 11 months. So that's your time. At an annual simple interest rate of 4.5%, how much interest will she pay? So basically, we're just looking for the interest. Interest equals the principal times the rate times the time. So if I'm doing this problem, what we need to make sure is happening is we don't know what the interest is. The principal is 5,240. The rate as a decimal, right? Percent means divide by 100. So 5. In time, 11 months is really 11/12 of a year. Okay, and they gave us that annual rate. Now this is simple interest, so it can be more complicated, but I don't think that's the intention, and now I'm forgetting because it's a different day when I wrote this out. Double check, yeah, okay. So we could definitely use a calculator or help us out with that, and by the time we punch it all in, it turns out to be rounded to the nearest cent, right? $216.15 interest in less than a year. 4.5%, actually a pretty good rate. So ideally, your parents say, save up, try not to take out loans, right? So the suggested practice, look some of them over.